The overall goal of my companies is to maximize the future.
On February 2nd, 2026, a short note landed on the desks of SpaceX and xAI staff. It did not look like a normal corporate update. It did not use standard business talk. The subject line was simple. It announced that SpaceX had acquired xAI, not a partnership, a full buyout. But the words that followed were the ones that stopped people cold. The memo described a plan to build a sentient sun. You heard that right? Sentient sun. Most people read that phrase and laughed. It sounded like a sci-fi joke. It sounded like something a billionaire types late at night. But if you looked past the weird words, you saw something else. You saw a map. A map that leads away from Earth. This wasn't about building a smarter chatbot. This was about solving the biggest problem in technology today. You already know what that problem is. You feel it when you pay your electric bill. You see it when local news talks about brownouts. The problem is power. AI eats electricity. It eats it faster than we can make it, and that hunger is hitting a wall. This script is about how SpaceX plans to break that wall. It is about a plan to move the heat, the noise, and the power load off the planet. It is about building a machine the size of a star system, and it starts with a simple reality check. The wall we hit on Earth. We need to talk about the power meter. It is the wall nobody likes to discuss. Right now, big tech companies are fighting a war for electricity. Google, Microsoft, and OpenAI all need more juice. They are building data centers that pull as much power as a city, but the grid cannot handle it. You have seen the wires in your neighborhood. They are old, they get hot. When you try to push too much power through them, they fail. Upgrading them takes years. Building new power plants takes even longer. Nuclear plants take a decade. Solar farms need massive amounts of land. And land is the second wall. Nobody wants a gigawatt data center in their backyard. These places are loud. The cooling fans roar day and night. They act like giant heaters, warming up the air around them. Communities are pushing back. They are voting no. Permits are getting denied. Then there is water. This is the part that really hurts. To keep chips cool, data centers drink water, millions of gallons of it. In places facing drought, that is a fight you cannot win. Farmers need that water. Families need that water. Tech companies are losing that argument. So here's the situation. The demand for AI is shooting up, but the supply of power, land, and water is flat. That gap is where businesses die. Elon Musk looked at that gap. He saw that Earth could not support the growth everyone wanted, not without hurting people, not without fighting for every inch of ground. So he pointed up. Space is called space for a reason. Musk made a joke in 2026. He said, "Space is called space for a reason." It was a funny line, but it was also a technical statement. Space solves the three biggest problems facing AI today. First, space has room. You do not need to fight a city council for a permit in orbit. You do not need to clear a forest. You do not need to worry about noise complaints. There are no neighbors in deep orbit. Second, space has power. On Earth, solar panels sleep at night. They sleep when it rains. They sleep when it is cloudy. To fix that, you need batteries. Batteries are heavy, expensive, and they wear out. In space, the sun never sets. If you pick the right orbit, the sun hits your panels 24 hours a day. It is a steady stream of pure energy. No clouds, no night, just power. Third, space is cold. This is the big one. We will talk about how this works in a minute, but the short version is simple. Space is a giant sink for heat. You do not need water to cool things down. You do not need giant fans. The environment itself helps you. This is why the acquisition happened. xAI needs massive amounts of compute. SpaceX has the rockets to put that compute where the resources are free. It is a vertical play. It brings everything under one roof. The impossible cooling problem. But there is a catch. There is always a catch. Moving a data center to space sounds great until you talk to an engineer. They will tell you it is impossible. They will point to one specific thing: cooling. On Earth, we cool things by moving air or water. Your car radiator uses air. Your computer uses a fan. Big data centers use water towers. All of these work because we have an atmosphere. Air picks up the heat and carries it away. Space is a vacuum. There is no air. If you put a hot chip in a vacuum, the heat has nowhere to go. It stays in the chip. The chip gets hotter and hotter until it melts. This is why people said space AI was a dream. You cannot run high-power chips if you cannot cool them. But engineers found a way. It is not magic, it is physics. They use something called radiative cooling. Here is how it works. Everything that is hot gives off light. You feel this when you stand near a fire. That heat you feel is actually invisible light hitting your skin. In space, you can use giant panels to shine that heat away. You do not need air. You just need surface area. The plan calls for panels that are about the size of a long pickup truck, 3 meters by 3 meters. These panels take the heat from the chips and glow it out into the dark. It is silent. It uses no water. It has no moving parts to break. This changes the math completely. On Earth, cooling costs money and power. In space, cooling is just a design choice. You make the panels big enough and the heat disappears. The launch enabler. So the physics works, but that leads to the next problem: mass. To build a data center in space, you need to launch it. You need to launch the chips, the solar panels, the radiators, and the metal frames. That is heavy stuff. For 50 years, this was the deal breaker. Rockets were too small and too expensive. Launching a single server rack would cost millions of dollars. You cannot build a business on that. This is where Starship enters the story. Starship is the truck that makes this possible. It is not like other rockets. Other rockets are like expensive moving vans you burn after one trip. Starship is built to fly, land, refill, and fly again. It can carry over 100 tons in a single run. That is a massive number. To give you an idea, 100 tons is as heavy as 15 large elephants, or a whole fleet of cars. Because it is reusable, the cost per flight drops. When the cost drops, you can afford to launch heavy things. You do not need to spend billions making your satellites tiny and light. You can build them big and tough. This is the key. Cheap launch unlocks heavy hardware. Heavy hardware unlocks space power, the sentient sun. Now we can go back to that weird phrase, sentient sun. What did Musk mean? He was not talking about the sun itself waking up. He was talking about a Dyson swarm. A Dyson swarm is an idea from the 1960s. A physicist named Freeman Dyson proposed it. The idea is to surround a star with millions of independent satellites. Each satellite catches a little bit of sunlight. Together they catch a massive amount of energy. The sentient part comes from what those satellites do. They don't just beam power, they think. They run AI models. Imagine millions of satellites floating in deep space. Each one has a solar panel to catch light. Each one has a computer to do work. Each one has a radiator to dump heat. They talk to each other with lasers. They form a giant invisible network. It is like a brain wrapped around a star. This is the vision. It starts small, but it scales up. The memo mentioned numbers that are hard to wrap your head around. It talked about adding 300 to 500 gigawatts of power per year. Let's put that in perspective. 500 gigawatts is huge. It is more power than some large countries use. Adding that much capacity on Earth would take decades of digging and building. In space, you add it by launching more units. It is modular. You build them in a factory, put them on a Starship, and let them fly. The integration play. This brings us to the business side. Why did SpaceX buy xAI? Why not just sign a contract? Because contracts are slow. In the old world, one company built the rocket, another built the satellite, another wrote the software, another owned the data. Every time those companies had to talk, things slowed down. Lawyers got involved. Meetings happened. Mistakes crept in. Musk likes to own the whole stack. He wants to control the launch, SpaceX. He wants to control the network, Starlink. He wants to control the hardware, the satellites. And he wants to control the mind, xAI. When you own everything, you can move fast. If the AI team needs a specific chip, the satellite team can design a slot for it that afternoon. If the satellite team needs a different orbit, the rocket team can change the flight plan. There is no friction. This is how you beat competitors who are stuck in meetings. While Google is waiting for a utility company to upgrade a substation, SpaceX is launching another batch of compute nodes. Speed is the weapon, the technical reality. Let's slow down and look at what this actually involves. It is not easy. Building these satellites is hard work. They have to survive radiation. Space is full of high-energy particles that like to flip bits in computers. A stray particle can turn a 1 into a 0 and crash your software. Engineers have to build shielding. They have to write code that checks itself constantly. If a calculation looks wrong, the system has to catch it and run it again. Then there is the debris problem. Low Earth orbit is getting crowded, but this plan looks further out. The Dyson swarm idea pushes towards deep space, far away from the traffic jams near Earth. Even so, you have to manage traffic. You need automated systems that steer the satellites to avoid hitting each other. You cannot have a human pilot for 1 million satellites. It has to be autonomous. The system has to fly itself. This is where XAI comes back in. The AI is not just the product. It is the pilot. The AI models will manage the swarm. They will monitor the health of the hardware. They will route data around broken nodes. They will balance the power load. It is a machine that manages itself. The competitive scoreboard. So where does this leave the competition? Right now, the scoreboard is clear. SpaceX launches 88% of all payload from the United States. They are the only ones with a fully reusable heavy rocket. China is building fast, but they are years behind on reuse. Their Long March rockets are strong, but they are not reusable yet. They fly monthly, not weekly. Blue Origin is flying, but their cadence is lower. They are just starting to ramp up. This gives SpaceX a window, a head start. If they can get the first generation of these AI satellites up, they set the standard. They own the orbital real estate. They own the frequencies. Think about the internet. The companies that built the fiber optic cables won. The companies that built the routers won. SpaceX is building the physical internet of space. And by moving the heavy compute off Earth, they change the cost structure. On Earth, you pay for power every month. In space, you pay for the launch once. After that, the sun is free. The cooling is free. Over 5 or 10 years, that difference adds up. It makes the space option cheaper. And in business, the cheaper option usually wins. A near-miss moment. But things go wrong. They always do. Imagine a launch in the early days of this program. The Starship is loaded with 50 compute satellites. It lifts off perfectly. It reaches orbit. The doors open. The satellites float out. They unfold their solar panels. They unfold their radiators. But then a solar flare hits. A massive wave of radiation washes over the fleet. On Earth, the atmosphere protects us. In orbit, the chips take the full hit. Half the fleet goes dark. The software crashes. This is the kind of moment that kills a normal program. Investors panic. The stock drops. People say, "I told you so." But because the system is a swarm, it survives. The surviving satellites detect the holes in the network. They reroute the data. They take over the work of the dead units. The mission continues. And because Starship flies often, a replacement batch is already on the pad. 2 weeks later, new satellites go up. The hole is plugged. That is resilience. That is what sentient means in this context. It means the system can take a punch and keep working. The middle third drought. We are entering the middle phase now. The hype of the announcement will fade. The real work begins. This is the boring part. It is the middle third of the project. It is engineers staring at spreadsheets. It is thermal testing in vacuum chambers. It is arguing about the weight of a bracket. You will not hear much news for a while. You might hear about delays. You might hear about a test satellite that failed. That is normal. That is how hard engineering works. People will say the project is dead. They will say Musk got distracted. They will say the money ran out. But watch the launches. If the rockets keep flying, the project is alive. Watch the factory builds. If they are making satellites by the thousands, the project is alive. The silence is just the sound of work getting done. Why this matters to you. Why should you care about a bunch of robots in space? Because of what it does for Earth. We want AI. We want better medical research. We want smarter tools. We want the benefits of this technology, but we do not want the cost. We do not want our power bills to double. We do not want our water rationed so a data center can run. We do not want our forest cut down for solar farms. Moving the heavy lifting to space solves that conflict. It lets us have the intelligence without the pollution. It lets us scale up our capabilities without weighing down our planet. It is a release valve for our civilization. Think about a factory town. The factory provides jobs and products, but it also brings smoke and noise. If you could move the factory 10 miles away, keeping the benefits but losing the smoke, you would do it. That is what this is. It is moving the factory to the sky. The financial logic. Let's look at the money one more time. Critics say XAI was burning $1 billion a month. They say it was losing money fast. They ask how SpaceX can afford this. That is a fair question. $1 billion is a lot of cash. But look at the asset. XAI has the models. SpaceX has the infrastructure. If XAI stayed on Earth, it would keep burning cash on power bills forever. By moving to space, that burn rate changes. The operational cost drops near zero. It is an investment in a lower future cost. It is like buying a house instead of renting. It costs a lot up front, but you stop paying a landlord every month. SpaceX is buying its energy house, and because they own the rocket, they get a discount on the moving costs. Strategic positioning. There is one more layer to this, a geopolitical one. Whoever builds this network first controls the future of AI. If the United States has a massive solar-powered compute swarm, it has an advantage. It can train larger models faster than anyone else. It can process more data. It becomes a strategic asset. Other nations will try to copy it, but they have to solve the launch problem first. They have to solve the reuse problem. They have to solve the network problem. That takes time, and time is the one thing you cannot buy. SpaceX has spent 20 years buying time. They did the hard work on Falcon 1. They did the hard work on landing boosters. They did the hard work on Starlink. Now they are cashing in those chips. The sentient sun reality. So is the sentient sun real? Not yet. Right now it is a plan. It is a stack of paperwork filed with the FCC. It is a team of engineers working late, but the pieces are real. The rockets are flying, the solar panels work, the lasers transmit data, the AI writes code. The barrier is not physics. The barrier is just execution. It is putting the pieces together in the right order. And that is what the memo was about. It was the starting gun. It told the team that the goal had changed. We are not just going to Mars anymore. We are building a new layer of infrastructure for the human race. We are turning on the lights in the attic. Conclusion. Space is called space for a reason. For a long time, that reason was distance. It was a barrier. It was a cold, dark place that was hard to reach. Now that reason is room. It is a place to grow. Earth is a garden. It is where we live. It is fragile. We should not fill it with hot, loud machines if we do not have to. Space is a factory. It is tough. It is ready for work. The bet SpaceX is making is simple. They are betting that the future of heavy industry is not on the ground. They are betting that the only way to protect Earth is to get off it. If they are right, the next few years will see the biggest construction project in history. We will see new stars appearing in the night sky. Not stars of gas, but stars of silicon and glass. If they are wrong, it will be a very expensive failure. But look at the track record. Look at the landings. Look at the internet satellites beaming data to your phone right now. The pattern is clear. They say it is impossible. Then they say it is too expensive. And then one day it just works. The sentient sun might sound crazy today, but in 5 years it might just be how the world works. The wall is broken. The climb begins. Watch the launches. That is where the truth is.